Okay, good morning, class. Okay, so we'll go back to lesson. There's quite a bit of math today. We will see how it goes. I'll look at your fatigue level and but don't just keep following the line. So this week there are no PE lessons because the PE department is all away and canoeing. So NJC is the convener for NSG canoeing. That's why every year the PE department is the organizer. Yeah, I heard it may change. Oh, yeah, so okay. Oh, want to find someone. Okay, so that's why you just take note that today's is math. Thursday lesson is history. If you just 中挑 your 去到 your so you still Thursday E is history lesson. Can okay, so these are the two. Okay, then okay, so the last time we stopped at question 1.5. Remember that okay, what we did is we went through the derivative of trigo function. Whenever we differentiate sine, what's going on? We differentiate sine, we will get cosine. Okay, start looking outside. Okay. Sine. Okay, differentiate sine, what do I get? Without looking at the notes. You cannot look at the notes. Okay, cosine. Okay. So Archie, differentiate cosine. Tyson, tangent. Very good. So this is the tree that we went through. Then we went through the chain rule. So remember that the derivative of chain rule have many different layers. Layer 1, layer 2, layer 3, layer 4. Okay, so before you start differentiating for trigo, try to identify the different layers first, and then differentiate one by one. Okay, so far? Then after when you differentiate, multiply them together. Okay. So I think we stop at question 1.4, 1.5. Okay, then we continue from there. All right, let's go. 2.1. Okay, it's two over. Okay, let me write the answer for 1. I'll start at 2.1 or who is done with 1.7 already? 1, 2, 3, 4. Okay. Just give me a second. Who has not finished 1.4? Okay. Who has not finished 1.3? 1.4. Okay. So I start from. Look at the answer. That's on the board. Question 1.5 is here. Question 1.6. Look at part 2 just chill a while. Okay. G prime, must write G prime X, not write G prime. Sorry. Question part 2. Okay, so this is the first going through of part 2. So part 2, similarly, you are the differentiating exponential function. Differentiate exponential function basically, right, is the derivative of an exponential function is actually itself. Okay, the proof is by first principle. But if you were to look at how, so let's look at me, exponential graph, right? Exponential graph, right? If you look at the gradient, if you look at exponential graph, if you look at drawing a tangent, look at how the tangent gradient is also exponentially increasing. Okay, yeah, that's why the differential derivative of EX is just here. So most importantly, you all must know the memorize like that's all. Okay, then after that, A power, this one we'll show this later. Okay, so what if you are differentiating e to the power of fx? Differentiating e to the power of fx, okay, can you see, think of this like outer layer, inner layer. Think of this like outer layer, e power something, that is outer layer. Fx, look at this as an inner layer. Is it okay? Brown and red. So layer 1, layer 2. Differentiate layer 1 is e power something, right? When we differentiate e power something, we get e power something. Number 2, layer 2. When we differentiate fx, then we just get f prime. Okay, that's why when we differentiate the derivative of e power fx, it's just f prime x e fx. Okay? And who's at part 2? If you are not at part 2 yet, it's okay. Don't listen to me now. You can try first. Okay, now question 2.1 might pose a challenge to some of you. Okay. So don't worry about it's basically chain rule. You can just multiply the formula. Okay, let's talk about a power x log a. This is not in O level. This is in A level. This is H2 mathematics. Okay. So but for NJC we learn it here. Okay, Alex, are you okay? Don't need you sleep. Okay, so we learn it over. I know it's a rainy Monday morning, but it's hanging there. Okay, differentiate AX is f prime AX. So derivative of e power x goes to e power x. Okay, in case anyone stuck at 2.1. 2.1, okay, so maybe I give you a hint. You agree that any constant a is the same as e to the power of log a. So can I say that if I want to differentiate a power x, think of it as differentiating a x is the same as e to the power of log a power x. Is that okay? Correct. Okay, think of this like f prime. Think of this like f prime. Okay, yes. So think of this like f prime. So when you differentiate f prime, then the f prime will be log a lah. Then it will be e to the power of x log a. Okay, so far okay ma? What lesson do you have before this? Why you look so sad? You got scolded? Then, don't scold you. It's just a Monday morning. But isn't it good? Tomorrow is HPL. Huh? Okay, wake up late. Go back. Huh? 12:30. Okay, wake up late. Wake up at 8 lah. Go eat McDonald's breakfast. Then 12:30 come. Joshua, stay focused. Okay. In the notes that I passed to one of you, you all still have it. Who did I lend the notes to? You took the extra book? Then you never return me. Then your other one? Eh? No, I found one. Oh, don't have. Anyone borrow my book? Take my book. No? I lent to you. Was there an extra book that I passed? Don't have. Oh, man. Don't have. Huh? My eyes red. My eyes is red since yesterday. Yeah. Not bad. You notice faster than my wife. My wife never even. Okay. Anyway, yeah. Okay. Question 2.2. One point seven. Okay, some of you are start at 1.7. Now, if you differentiate gx, okay, then g prime, okay, I will use the product rule. This is u, this is v. So differentiate u prime is 2x multiplied by cos 3x. Differentiate cos 3x, negative 3 sine 3x multiplied by x squared plus k. Okay, if you do not want to simplify this, I guess that's fine. Let's just write it nicely, removing the brackets. Okay, now you know that this is negative pi squared. So sub in x equals to pi over 2 and g prime equals to negative pi squared. There you go. You have negative pi squared equals to 2 times pi over 2 cosine 3 times pi over 2. Okay, subtract 3 of pi square over 4 plus k sine 3 pi over 2. Okay, just work this out slowly. Work this out slowly. Oh, 2 times pi over 2, this will just be pi. Cosine 3 pi over 2, it will just be 0. Minus 3 pi square over 4 plus 3k. Sine 3 pi over 2, negative 1. This is equal to negative pi square. Okay, then divide by negative sign on both sides. Pi square is equal to 3 pi square 4 plus k. Yeah, simplify this. You should be able to get that k is negative 7 pi square over 12. Okay, this is question 1.7. Question 1.7. Okay, then hence find the equation of the normal where x is pi over 2. Where x is pi over 2. Okay, so if x is equal to pi over 2, what is the gradient? Okay, so you know that when x is equal to pi over 2, g prime pi over 2 is supposedly negative pi square, right? This is the gradient of the tangent, don't forget. So what's the gradient of the normal? The gradient of the normal is none other than 1 over pi square. Okay, this is the gradient of the normal. I just need to take a negative reciprocal. Okay, after that, y minus y1, gradient x minus x1. And x equals to pi over 2, sub in, y should be equals to 0. Okay, now you have y1, x1, gradient. So use the equation y minus y1 equals to gradient x minus x1. Y minus y1 equals to gradient x minus x1. Then your answer will be as follows. Okay, this is for question 1.72. Yes, you can. Only question. Okay, anyone start any question? Yeah, 1.5. Okay, so let's go to 1.5. Which one? A, B, or C? B. So if I look at B, right? Okay, maybe can I look at it this way? I look at it as y equals to tangent x power half the whole thing to the power of 2. Possible? Possible, huh? Okay, so you look at the brown as a first layer. You look at blue as second layer. You look at the pink as the third layer. 看得到吗？ Can So 3 layers, differentiate layer by layer. Okay? Can anyone start at any question? Oh, Kang Yu, I saw you. Hey, can I? Entire in terms of y means all your variables must change to y. There will not be any x present. Question 2.2, right? Question 2.3. 2.3.
I already did the dx part. I found out what's the dx. Which is just half e to the power of x minus e to the power of x.
So you took this one, you differentiate, right? Okay, wait 1 second. You find your dy dx. I believe you got here. First step, checkpoint 1, you will be able to obtain that dy dx is 1/4, right? Is it 1/4? Sorry. Half e power x minus e power negative x, right? So you look at this one, right? Then you look at perhaps what is dy dx squared plus 1. Okay, so let's try this out. 1 plus dy dx squared is the same as 1 plus half e power x minus e power negative x. You want this to be in terms of y, right? Oh, there's a half here, sorry. Oh, it's a square. Okay. So I take 1/4. Is it okay I do like that? Yeah, square. So I get 1 plus 1/4 dx minus 2 plus e minus 2x. Am I right? 2x. E square minus 2ab. 2ab is just 0. Right, huh? Right, huh? Because 2 here, right? This is A, this is B, right? 2, yeah, 2, this is just equal to 2 e power 0. It's 2. Okay? So I put 1/4. Can I say that this is e2x minus 2 plus 4 plus e minus 2x? Can I say that this is 1/4 e power 2x plus 2 plus e power minus 2x? What do you don't need? What do you think this is giving you? Ha ha!
Square of
Yes. You are smart enough to see this out. Is it y square? Yeah, y square. So if I square root this, right? This I square root this, square root, square root, square root, square root, half y. And life is good. No. Not half 1/4 y square. 1/4 is square root of half y square. Is it? No. This is not 1/4. Yeah, it's actually just y. It's actually just y. Yeah, because it's half. So 1/4 is actually y square. Half of y square. 1/4 is half of y square. Oh. Alex, can you sit up straight? Stop putting your head on the table. Yeah. Can I go through which part 2? Part 2 or notes? Notes, part 2. Okay, so notes, part 2, you will go through the derivative of exponential and log. So exponential function, basically, if you look at e power x, right? If someone say your IQ is exponentially increased, it's a good thing. It means that at the rate of time, along with time as the x-axis, your graph, your intelligence is climbing exponentially. Right. So if you look at exponential function, if you look at how fast, does it make sense? The gradient also will climb exponentially fast. That's why the derivative of e power x is actually like e power x. But the proof is actually by first principle, which I will show now. More importantly, we want to is not to use. Because the derivative of ex is just yes. Yes, it's 2.7 something or 2.7. Huh? Can I? So in fact, it's not just e Lx. Like even if I give you 5, 10 to the power of x, these are also exponential. Okay, e doesn't come from this. It's not e because of this value. This is the Euler number. We don't call this. It's not because of it, but rather a power x, 3 power x, 7 power x are all exponential function. So now I talk about once I need to sell you this, then I sell you this one. Power x. Yeah, this is easy, but nobody's going to test this for except no one test this one. E power fx. So e power fx, we look at chain rule, right? So if you see e power fx, notice how this is outer layer. The one in brown is the outer layer. Okay, the one in brown is outer layer. The one in red, that's the inner layer. Layer 1, outer layer. Layer 2, inner layer. See, okay. Still okay? Still okay? And so now, chain rule again is just by differentiating outer layer times inner layer. Okay? So that's why I differentiate outer layer, differentiate inner layer, outer layer here, inner layer. Differentiating e power blank will give you e power blank. You'll differentiate ex is ex. Differentiate fx will give you f prime. Okay? So you can see the derivative of layer 1, differentiate layer 1, multiply by differentiate layer 2. That's chain rule. Or just multiply together. Okay? Okay. Now for a power fx, first we need to do a power x log. Okay, so let's assume that you all have proven this. I've managed to prove this. You prove this first. Then I go through. Hold on. Okay, yeah. 2.1? 2. 1 second. Still at 1.5? Anyone still to 1.5? Joshua, what question you had? 1.4. Try to hurry up. Question 2.4. Point three is just true. Question 2.3 is just equal to 1. .4 is here. Question 2.5. Oh my god. Oh. Yeah, go around and take a look at your